Okay, so I figured I'd try to make a little intro to wood turning, starting with the machine. Obviously, you'll have a tough time wood turning if you haven't got a lathe. Sorry, I need to adjust this thing. I don't normally hold the camera. So, so this is a lathe. Obviously, this is a VL300. This is the lathe that I use every day that I can. And I was just going to show you all the basic parts. Actually, I will have to put the camera on the tripod here so I can move around and point at stuff, and also put the tool rest back. Alright, so I've been working on a doc that basically describes all the basic parts of a lathe. There we go, so you can see what I'm doing. And so headstock, ways, base, banjo, tool rest. Goes there, and then at this end we have the tailstock. So the VL300 has a swing away tailstock support, which 80% of the time gets the tailstock out of your way for when you are working on the inside of a bowl. That 20% when it doesn't work is when you have to sort of swing the handle of your gouge through the space where the swing away has put the tailstock. For the Vicmark, the only solution is to put the tailstock on the ground. It weighs about 40 pounds, 45 pounds, I guess. Maybe a little more. And there are a couple of other manufacturers that have a, here, I'll show you the swing away part. So as you can see, the swing away is a little extension of the ways, and so when you undo this, if the tailstock's on there, you can push it out of the way. There's another advantage to having a swing away bed extension, and that is sometimes you want to stand right where this is, and that's one of the reasons I did not get the long bed version of the VL300, is because my other lathe, my previous lathe, is a Geo766 Grizzly, and the bed is probably a little over 4 feet long, and so it's impossible to stand where the swing away is, and so what you end up doing is sort of leaning way over the ways in order to get inside the bowl. So the video that I'm going to make, and I need to put together the parts for it. Oh, other parts. This is chuck. Technically the chuck is the base part. So it's this cylinder, and then attached to that are jaws. These are 130 millimeter jaws, roughly 5 inches. This is a Technitool. This is a Titan 3 made by a company called Technitool out of Australia, and they are probably, I think, the most popular. I would say they're probably the most popular chuck manufacturer for hobbyist turners, and obviously for turners that have gotten a bit more serious. Someday I will probably upgrade to Vicmark chucks. The company that makes this lathe also makes chucks. They are a higher quality in that they're heavier construction, and from what I've been told, they last longer, but I haven't really had any problems with the Technitool chucks. I have all three of the 4 models that they make. This is the Supernova 2, which is the step up from their hobbyist chuck which is the G3, which is this little guy. And so, yeah, so I've got about, I have a lot of chucks. And the reason you end up with a lot of chucks is because after a while, you have a lot of different jaw sizes, and you don't want to have to keep taking all those little screws out and swapping out just to change out the jaws. So eventually you end up with roughly as many chucks as you have, well, as many as you can afford, actually, but as many as you have sets of jaws that you use most commonly. In my case, that seems to be around 5. So, other important parts of the headstock that I talk about in my document. This is the spindle. Goes round and round. This is a 1 1/4 inch, 8 thread per inch thread. You need it to match up with whatever chucks you buy. The Technitool does make an adapter series where you have basically a threaded adapter that fits your spindle, and then it threads into a slightly larger threaded port on the back of the chuck. I prefer to get the pieces that I prefer to get the chucks that fit my spindle, because that way there isn't more distance between the headstock, which is hopefully the most stable part of your lathe, and the chuck. So the more length there is between the headstock and the piece, the more potential for vibration. I do have an adapter which I use sometimes, this little guy, and so this is a 1 inch 8 TPI, which is the same size as the Jet 1221 uses, the guy that I use the G3s on. And then on this side, this is a 1 1/4 8 TPI. So I can thread this onto that guy and then throw a Grizzly or a G3 on there, but I don't do that very often. Normally it's because I'm being lazy, I guess, because I don't want to move all the jaws that I have on the G3s over to the larger chucks. So, what other parts? Yeah, so spindle, this is, let me bring this over a little bit. So, down here we have the variable speed control, which controls the motor speed. And then there's a belt that runs from the motor, which is underneath in the base. Really nice place to have it. And to the spindle. So there are 3 pulleys in here, and then depending on the ratio of the headstock pulley and the motor pulley, that changes the ratio of the motor to the spindle. So you have lower speed, higher torque. You have the happy middle ground, which is normally where I leave it, and then you have the high speed, lower torque. I don't really turn at really high speeds because I don't do a lot of small spindle turning. Most of the highest speeds, 2,000 and up, are typically used for pens, things with a very small diameter, where you want the surface speed of the piece to be fairly high to get a good cut. But since I do mostly bowls and sometimes I do cores, so if you take a large blank and you remove, you basically scoop out the middle of it, you want to be on the lowest speed, highest torque setting, because it's a lot of work for the motor, because you're using a scraper, basically. It's a fairly narrow cutter on an arc. I'll do something on that in a different video. And so for that, you want the lowest torque, otherwise you could stall out the motor. And this is a 3-horse motor, so this is pretty much this. It's not the most powerful, but it's the most powerful commonly available lathe. I mean, you can certainly throw in much bigger motors, and some people do because they turn insanely large pieces. But I find 3 horses great. 220 volt or 240 volt, depending on your point of view. And yeah, The only time when I've changed it is when I had to core. Typically, I like to be turning around 1500 RPM. A little slower. The last piece I did was about 8 or 9 inches across. I think I turned it around 800. But it was also a little bit gnarly. So on the back here we have the hand wheel, which is great for putting your chucks on. You want to be careful when you're first threading these on. Obviously, it's like a nut and a bolt. You cross thread it, you'll regret it. And then that's a little Glenn Lucas thing, do a little snap thing. But what it does is it tries to ensure, and you want to make sure that the surfaces are clean on the chuck and on the spindle, so that you don't end up with little bits of sawdust and things, because I don't know if you know, but wood turning produces a lot of sawdust. I mean, like a lot of sawdust. And it gets in there, and if it's in there, it'll cause the chuck to be slightly out of line with the axis of the lathe, and your piece will wobble. So I try to keep those surfaces clean. Back here there's a pin, it's called a spindle lock, and it allows you to do things like, it also doubles as what's called an indexing pin. So for instance, there's a position there, there's the next position, and so this is something that people use for laying out patterns on the surfaces of pieces, spiraled, what are they, candlestick posts, or some of the other things like balustrades and things where they have grooves. The indexing is how you get those grooves nice and even. It normally also requires a jig. You don't just bring your router or your Dremel up here and zip along. I suppose you could, but you probably don't want to. So typically for things like that, you want a rail system that will keep everything moving evenly and will keep the cutter under very tight control. As you can see, I also keep a cabinet scraper here. I don't know if you can tell. I often use that for dealing with some of the torn grain and complicated stuff where sandpaper just seems to be going too slow, or I just want more control over a particular part of a piece. Lots of Allen wrenches. This one I think is an 8 mil. Yeah. This is the one that came with the chuck. It's okay. It's got one of those little universal ball sockety things, so sometimes that comes in handy. But if you, and this is a trick that I picked up in a Stuart Batty class, but quite often what you do is you just sort of, you want to make sure it's seated well, but you don't want to do that if this has a little ball socket. Alternative ways to pull these off, just in case, I keep a strap wrench. These work really well as long as you can get them around the piece. I put a little bolt through the end of this guy so it wouldn't pull through, and then you just sort of pull down on it. So sometimes I have to resort to this if it's really tight on there. So yeah, let's see. Yeah, tool rest, banjo, talked about that. So over here in the tailstock area, so this is referred to as a live center because it turns. There is such a thing as a dead center, which I don't think I even have one. Both of these inside angles are a Morse 2 taper, which is probably the most common one. Some of the smaller lathes or some of the older lathes have a different. There was a Morse 1. Apparently, it's a bit. I don't know. It just went out of. I guess it had some failings, and people decided that the Morse 2 diameter and angle was better. Some tailstocks you need to use a knockout bar, which is just a metal rod, and a lot of them they have a back off ejection pin. So once you get these down to 0, I think this is coming through. Yes. Okay. Once you get to 0, you give the wheel a little bit more turn. And because of this, sorry, I keep moving back and forth trying to find the camera. Okay, because of this little ledge here, and there's a pin in there, when it hits that, it actually, basically the quill can pull back a little bit further and it pops this out. Some aftermarket live centers don't have that, and some of them are also, well, this one's solid, but some of them are hollow. And so if you try to use a knockout bar, a lot of times what will happen is you'll end up knocking out the pin. Workarounds for that are to like get a screwdriver in there and try to jiggle it loose. I was thinking maybe there would be a way to fill in that hole, maybe fit a bolt or a screw there, so that when you push in a knockout bar, it's got something to hit. Another thing you can do is you can kind of try to push the knockout bar at a slight angle, but because of the length of the tailstock, it's not much of an angle, so your mileage may vary with that one. Other things that I have here that I find really useful are these work lights. So this is 6,000 Kelvin. I forget how many lumens, but I want to say it's about 800. This one I think is also about the same intensity. So as you can see, they're very flexi-bendy, so you can point them right at the piece as you need it. This one's here for looking inside the vessel normally, and this one is for getting a better view of the outside. So the two of them, I didn't know if I would actually need or want two of them, but well, I did want two of them. I didn't know if I'd need them, but I find both of them quite useful. So, and they're held on with these really strong magnetic bases. Over here, as you can see, I have a collection of all my different gouges that I use. The most common ones are the 5/8" bulge gouge. These are one-way gouges, which I get from Woodworkers Emporium. They have a 40/40 grind, and I think I've already done videos on grinding, but I can probably do another one. And then I use the Stuart Batty bolster system, so that I can take, say, this handle and move it from, this is a bottom bowl gouge, I can move it from there to here, and then just hand tighten it. You don't really need to torque these down for the most part. And now I have I don't know what this is, about 22-inch handle. This is actually a handle that I cut off of a tamper that broke. And then you can buy the bolster ends, and then you just drill this. And then I used JB Weld to glue that in. And so that makes it much easier to move between different types of cutters. I also have, like, this is my spindle gouge. I'll be using this when I do the mallet askew, which I might use. A couple of different scrapers. This is a thin parting tool. I'll do another video on all the different gouges and such. And I think that's a pretty good intro to wood turning. Those are all the parts, other than safety gear, respirator for keeping all that dust out of your lungs, especially when you're sanding or dealing with spalted wood, where there's lots of spores and things in the wood that would be quite happy to grow in your lungs if you let them. And by far the most important piece is a shatterproof face mask and a rag to clean off the dust. There we go. I changed these out. I changed out the plastic probably twice a year, I guess. I get them in, I want to say they're 12 packs, 8 packs from Amazon. Because the frames themselves, unless you have something truly horrendous happen, I can't imagine what in this plastic frame would break. But these guys, they get scratched, they get coated with glue, glue you can take off, but some finishes, they stick on there, they etch the surface. The scratches themselves, probably because I'm using not the cleanest rag in the world. It's very important to be able to see what you're doing. I haven't found any value in the anti-fog ones. Quite often the best thing for fog is wipe it off and keep going. It tends not to be too much of a problem. I think it's worse in the winter when the face mask is much colder. During the spring, summer, during summer and fall, it's not that bad. Anyway, hopefully that's not too much rambling. I'll stop this video and then put together the mallet video next.